Hello everyone. We're going to get started now. So, first of all, thank you very much for coming, and thanks to for sponsoring this event. My name is Shashi. I'm a meetup organizer. So today we have 3 talks. First of all, we'll be introduced how the Huddle test software, and then I need to go to the James for the PhantomCSS stuff, and then we got Adam, who has traveled all the way from Israel to talk about visual regression testing with Selenium. So before we start, I'll just take a couple of minutes to talk about the future Selenium events and what we're going to do with this meetup group. So we got one today. There's one planned for next month, which is about mobile Selenium. We got speakers from Source Labs, one who is creator of APM, and another one which is from the Destroy. So that event will be awesome again. If you haven't signed up yet, please sign up for that one as well. I will confirm the details soon. If you want to submit a talk for the future events, we have created the talk submission page where you can put your talk details and what the topic you want to cover, so we can get that covered in the future events. Now Selenium is on GitHub officially because Google code has been shut it down, so you have to look at the GitHub repo. Yeah, that's it really from my side. I will hand it over to the Phil to talk about speed event coordination.
Yeah, first of all, I just wanted to say big thanks to Shashi for setting this up, and also Birdie. I'm not sure if you can see him here. He's our internal recruitment, who's responsible for making sure that there were pizzas and beers and all that kind of nice stuff. I'm going to give a brief overview of some of the issues that we have in Huddle with a legacy web automation solution. It will kind of veer into some of the architectural solutions that we have for that problem that we'll be adjusting in the software itself. Some of the workarounds that we'll put in place to be able to make sure that we don't have to deal with it for a very long time. And it will also segue nicely into Jim's Crier's talk afterwards, where he the visual regression testing and using PhantomCSS. And that one is actually quite a large part of us being able to get away from the slow, cumbersome nature of LDN tests. So as of this morning, you guys will probably have all known that luckily Internet Explorer is dead. It's end of life now. That's a really good thing for us, but it's not quite there yet. So we still have to deal with it for a couple of years. So we still have to put solutions in place for that. Right, lay of the land at Huddle. The architecture of the application is kind of it's got 2 faces. So it's a large monolithic application from the past, but we're also building out new services as well that are kind of breaking that into smaller, more manageable chunks. Now, the kind of the test framework that you put in place for something like that requires that you're releasing longer frequencies because you've got lots more stuff that can change, and you're not really sure about whether one change can propagate to another part of the system. So you generally release slower. So you release about once a month. Requires a long regression phase. You need to put lots of QA on that. You've got to get lots of eyes on it to be able to make sure if something's gone wrong. We have lots and lots of Selenium tests, which is a good and a bad thing. The good thing is that there's a level of coverage there. The bad section of that is that it's actually quite slow to run an end-to-end test over a large system. Whenever you multiply that up, it just gets longer and longer and longer. The reason that the Selenium tests were there in the first place was because of the kind of the lack of unit tests at the lower level and not really described components. So it's very difficult to write unit tests for stuff when you don't know where one unit stops and the other one starts. And we also have the issue where the UI is coupled to the back end. There's going to be a little bit more about that from James's talk, but essentially, if your UI is coupled to your back end, you need to have the back end up to test your front end, and that's where you've got that lag, that time that it takes to execute the tests. Okay, so the new components that we have. So they are release on demand, much smaller, and they're very discrete components. The regression test forms more of a smoke test than a full regression cycle, because the surface area of change is small, the application is much more manageable, and you've already tested all of the features as and when they go in, so it's very easy to isolate any region. In comparison, there's very few Selenium tests because it's more about the hookup between the UI and the backend that we're looking for. Lots and lots of unit acceptance tests, and the UI is a separate component, and yeah, we just talked about that. So, what did our Selenium suite look like? The test execution time is around 4.5 hours. That just makes it infeasible to do any kind of proper CI. Really what we're looking for is about 10 minutes on a proper feedback cycle. So 4.5 hours was unmanageable. We had high test complexity, so many of our tests went through so many different clicks, so many pages, that if one of those little pieces of the puzzle fails, it can propagate quite badly through lots of tests. And it doesn't quite point to the root cause. So, you know, if you have one component that moves places, it actually breaks quite a lot. We had intermittent failures due to the test executors. Now, when I say test executors, I mean like, you know, the builder, the test agents. So the versions of Firefox that they had on, the environment in which it was executed. And we also have lots and lots of data builders that are coupled to the SQL schema. So because the setting up data before you actually go into the application is coupled to the schema, any changes at all start to break your web automation as well. So you start increasing the amount of time it takes for you to find these issues. So what are we trying to do for that? Well, essentially, we're saying that this is a monolith and it's going to die. You know, so we're breaking it apart into different sections that are much more manageable, much more like the first set of the problem. So what we're trying to do is buy time for re-architecture. We're trying to say that, you know what, in about 12 to 18 months, that will no longer exist anymore. So we'd like, you know, rewriting the entire test framework for something that you're going to throw away in 18 months is actually not feasible. It's not a worthwhile investment in time. But in the meantime, 18 months is still comparatively a long time to wait for that 4.5 hours feedback cycle. So what we're talking about trying to do is to make the test faster, make them more reliable, and we need to do this with the lightest touch possible. So we need to keep everything in place until the point when we can just let it, you know, drift off into the night. So the solution for that, 3 phases. First one, we needed to stabilize the test execution environment. We needed to control the browsers that we're actually going to be executed on. We need to introduce parallelism. There's no point in having all these machines at your disposal and not, you know, all that CPU power and not actually use it. So we want to parallelize it. And the thing that we can do after that is just throw machines at the problem. So we're saying that actually, in this case, we're going to use hardware to solve the software problem because it's a disposable solution. It's there as a means to an end. It will get us to the end goal whenever we've moved over to a near test strategy. So for the stabilizing of the execution environment, we built a framework that allowed us to spawn new VMs from scratch. And it's very difficult to read this actually, so most people won't see it. It's essentially a bit of a manifest, and it kind of says what the name of the machine is, the version of the operating system, IE version, Firefox version, and then a bunch of IP settings. But essentially that allows us to build up an entire hypervisor filled with machines of a given spec that we can actually start running these tests from. It makes sure that all the prerequisites are available, and this is a bit of a pain for things like certificates. We're in control of the creation of these VMs, we're in control of the certificates that we put on that are compatible with our environments. The specific versions of the browsers, and it's also about being able to say, do you know what, if this machine for any given reason gets dirty, it's fine, we just blow it away, and then we spawn a new one. We're not beholden to keeping that machine alive and having to look after it with some TLC. We can just get rid of it. Introducing parallelism. So this, again, it's light touch. It's very, very light touch. The way we went about it was we actually said that we're going to load, probably some background on this. We're a .NET house primarily, so we're using C# and NUnit. And all this bit of code is basically doing is it's going through, using reflection to pull out all of the information about the tests contained within the DLL. And it's saying, well, if you split off by category, then we can essentially get a new list of tests that we can respawn sub-processes for. So in the next phase, all we're doing is we're doing the spawning phase. And we've already got the list of test cases that have come out from that, so we know where they exist. We can do it based on test category or test fixture or anything like that. In this case, we've decided to go for test fixture. So it'll go through, find every test fixture that matches the category. So say we have a category called the admin section or the account settings. Each of those would have lots of different test fixtures. It's basically saying for each of those categories, the test fixtures will spawn a sub-process. And that allows us to, we've got flexibility over that depending on the machine. So we get configurable degrees of parallelism. So that just means that we can say you're allowed to run a maximum of n sub-processes. So if we want to do at the top level, you can say run 5 sub-processes. It will find the first 5 in the list, run those, and then it will just start popping and popping and popping. It's 3 times as fast as before with 5 concurrent processes. It's important to know that it's not linear. There is diminishing returns on this, so you can't just widen the pipe and put it to 100. It doesn't quite work like that because you are limited by the machine spec. You can't just keep spawning new sub-processes in the machine and then expect it to keep it properly. So there is a sweet spot to be found on that. And the final thing is now that we can parallelize these, now let's throw more machines at the problem. So our first set of the problem was actually that we didn't have enough build agents to be able to run every single one of our test suites at the same time. But we've already built the framework now to be able to build up arbitrary machines. So we use that same framework to be able to build up build agents to be able to execute. So essentially we can run all test suites at the same time. We run every test fixture in parallel with each suite. And because of that, we can start creating more granular test suites. It means that whenever one build agent is finished with a 2-minute test, it can move on to the next test and the next test and the next test. And you kind of get this kind of sorting pattern where even if you've got a long-running test and a short-running one, the build agents start to recycle and still keep that time within a certain time. After all of that work, the execution time came down from about 4.5 hours to 15 minutes. Now, that's starting to get into the realm of being useful for CI. It's not quite there yet, but it's almost there. And that's without throwing Selenium Grid at the problem as well. So, again, you can throw even more machines at the problem. You can actually start to say, you know what, I'm going to start servicing all of these requests off on a separate grid. The execution of the tests themselves are still in the build agent, but it will be firing off commands to the grid. And because of that, we can take care of the issue with the machine spec. So we can only run a certain amount of Firefox sessions on one machine. But actually, you don't care about that anymore whenever you've got an entire grid of browsers available. You don't have the RAM and the CPU overhead in those sub-processes. So by moving to Selenium Grid, we'll be able to actually start boosting the ceiling on the concurrency that we run in those sub-processes. Uses exactly the same mechanism for building machines. You get the double fan out for parallelism, so by parallelizing the test case execution and also parallelizing how many machines it can do out to, you can kind of double your speed. And it balances that load from specific tests. So this is where you kind of get into the weird realm of sometimes adding like a wait and a sleep is actually more cost efficient, because if you're executing these tests and it's running in parallel and you have one of them that lasts for 10 seconds and one of them that lasts for 3 seconds, boosting that test that takes 3 seconds to taking 5 seconds doesn't actually speed you up anymore. It doesn't slow you down, because your bottleneck is your 10-second test. So sometimes even adding time, sleeps, and waits is a quicker way to solve the problem to get you to that kind of 18-month point where you're going to get rid of all of it. And yeah, you can start increasing the parallelism on executors until they can no longer launch browsers. So that's pretty much it. Summary: Internet Explorer is dead to me. It's done. Parallelism is absolutely paramount in getting fast feedback on food, because that's what we're trying to get. We want, when a change occurs, we want early feedback about a problem being introduced, and that's exactly what the speed of execution of these is going to bring us. And the final point is, sometimes throwing hardware at a software problem is actually a really cost-effective way of doing things. So there's very little code that had to be done for this. Doesn't take an entire team to rewrite the entire test suite that's going to be thrown away. And again, it's just a machine that's whirring away in the background. So that's it from me. Does anybody have any questions about that?
In terms of hardware, you use AWS, or you have your own machine?
So we'd priced out AWS, and for the scale of machines that we're looking at, it was actually easier to just get a hypervisor in-house. So I think a hypervisor costs is $5,000 for a hypervisor. Now, in that hypervisor, you can host, 45 machines. That's more than enough for our purposes. If we had to scale our business more and our development more, and we had to add more machines to the process, we would just change the connector that builds up on hypervisor, and we would write an AWS connector instead. But it's about half the price of going into the AWS at this scale. It starts to get much better the bigger you get.
Is there a reason why you decided to write the parallelized tests in NU framework as opposed to MBU and XU, which have parallelism?
So this is all legacy. So everything was already written in that language, and it was about matching the interface and being as light touch as possible on the application.
There was one challenge in your slide where UI is coupled with backend. Can you elaborate on what exactly the issue is and what the solution?
Yeah, so the UI being coupled with the backend was because it was single-page applications. Like we were using server-side rendering, and all of that stuff was actually meaning that you couldn't just separate out your UI, and it's not just a bunch of JavaScript and CSS. It's actually intrinsically linked to the backend, so you can't just test the UI without having the backend up and running at the same time. Does that answer your question?
So you need to extract the data from the SQL database.
So the challenge for that was that we couldn't benefit from James's work. And James's work is about visual regression and being able to test the UI in isolation. And we weren't able to leverage that kind of framework on those kind of tests, because we need a fully running system in order to test that UI. And the legacy part of the application. The new part of the application is not the case. Yeah.
Yeah, so when you start it's like 4.5 hours. Was it 4.5 hours reading time? It's very slow.
Absolutely.
You end up with you end up with like a quarter of an hour reading or quarter of an hour, but actually still the same half hour rate, but a lot faster. But you end up with reading in a quarter of an hour and reading in or you're still getting the flow.
So the first step that I put in the solution there was to stabilize the tests. So the first stage was to get them reliably read. There's no point in introducing parallelism and all of the other complexities that come with that until you've got a stable base to build on. If you start, things will feel faster, but you won't know if it's as a result of parallelism or as a result of flaky test, or your sequence changed. It would be very, very difficult to actually figure out what the problem is. So it's much easier to say, you know what, we're going to get it green and make sure that it can reliably give a 4.5-hour turnaround time for all the tests running. And after that, you say, right, now we're going to introduce parallelism. It's very much stable first, then make it faster.
What happens to these machines after the run? You have the 15 minutes run, and the machines you produce, do you crash them, or do you continue to use them? Or?
So these machines that were built, they just stay in TeamCity as an available executor. So if somebody else then wants to run a test, it will pick up one of the available machines. And it does mean that during the night, you're practically, there's no capacity on them at all. But again, it's still more beneficial than using the AWS.
So the difference
So there's quite a few things. One of them was weights. So we did have quite a few parts of the application are asynchronous, and sometimes the result comes back by a certain time, sometimes it's not. We've done waiter objects to wait until things are aligned. We have tried extracting out some of the other stuff that is really coupled to SQL and start retrofitting it with some APIs. And that gives us our kind of buffer in between the two. There are lots of other bits and pieces that we clean up of, the way the tests were written in the past and kind of sanitizing those. And some of the other things that were cleared up were like, obviously we're an authenticated application. We have to go via a login screen. Not every Selenium test needs to do that because it's actually not beneficial to go through the login screen every time. You want to test login once, and if login fails, that one test says it's failed. You don't want all your tests to fail because login is failed. So we also then wholesale changed everywhere where it was logging in and logging in and logging in. And if some part of that just kind of slowed it down a little bit, we just started injecting in an authenticated cookie and going straight to the page that we want. So there are lots of bits, but I think for everybody it'll be slightly different based on how they built up their web solution.
How did you inject the cookie?
Say again?
How did you inject the cookie?
Into
Authenticate.
just whenever you're requesting the page, you can add cookies into the automated session. So in say you've got a Webdriver factory or something similar that you instantiate your Webdriver, you can add a cookie into that session. So we get that cookie as well via an API that our application hosts, so we can mint our own OAuth cookies. Grand. Okay, so I will hand over now to James Cryer, who's going to talk a little bit about PhantomCSS. Thanks. And there's probably time for another beer if anybody can find one of the bin. Not the bin, the bucket.
Really good. Yeah,
So every minute there's a little chunk. Yeah, so you go in education. On this one, it's like 7 days, 5 days. The still 10 days. So 10 days more or less takes 7 days. Oh yeah. So the second version, they announced it. I signed up for that. Yeah, so that's 7 days. Then they got the still version. Exactly the same. Smart faces that say, "Oh, I think it last a day." You know, what? Yeah, just you went like this one. It's like just click on this. I'm going to like take it off and then hello everyone. Hello.
Hi, I'm James. So I haven't talked about so many about visual regression stuff. It'd be worth just having a quick chat about, leading on from what Phil just spoke about where we've gone architecturally and how we've gone into testing, which will bring us, hopefully segue us nicely into visual regression. This little project here is one of the many things that came up and developed here. It's basically about how we have a monolith, right? A monolith application that's mainly server-side, generates server-side templates. The way we're progressing architecturally is that we are building SPAs, JavaScript applications, that sit on top of a container, a server-side container, and the UI and all of that is held within this encapsulated SPA. And that is separated by a server via APIs. So in terms of how we separate UI testing, uncouple UI testing from the back end, we do it by mocking XHR calls. So that basically, I just want to cover that because I know it came up in previous sessions. So we use this technology here, which is using PhantomJS to basically mock out the just the XHR calls, and because all the state and the dynamics are driven in S-file basically on click events and by responses from the server, we have control over each end. Yeah.
What is an XHR?
It's an Ajax request. So, yeah. So it's all Ajax RESTful API stuff. So basically we have control over each end, and that allows us to have a separate UI test suite that's not end-to-end. Why would you do that? You do that because it's really fast. And you can also use PhantomJS. So about 3 or 4 years ago, I guess, we used to use Selenium for all of our testing, including our UI testing. And that was fun. The problem is not Selenium, the problem is end-to-end, right? And all the possible variables you get between the user clicking that button and that bit of data going in the database and coming back up again. And so we needed a way of just making it less flaky, making it more stable, making it faster. Because at the end of the day, it's about, if I run a test, I want that result to come back immediately. I want to know if it's broken. And this is especially useful for developers like me who really want to know if they've just changed some code if something's broken. So there was really this strong emphasis, given that we were already going towards this kind of spiral architecture, there was a strong emphasis on moving away from Selenium to other testing. We had to look at, as a side note, we had to look at Jasmine as well, and the level of mocking involved in standard Jasmine tests was a bit too heavy for us. So this gave us a nice solution where we could just wrap up the whole UI and test it as a separate thing. So, on to the actual presentation. So one of the things that came out of this, obviously, getting that isolation was great. It allowed us to, let's say, test quickly, test in the language that I'm familiar with, which is JavaScript as well. That's why we chose PhantomJS. But it didn't resolve all the problems. And the problem that I've been a Hudl like 6 years, and the problem we've continually had is trying to use Selenium or use whatever test Phantom when we adopted it, to test to say if a button is disabled, and to test if a button is disabled, or you test that class name as the disabled class name. Right? But of course, if I then choose to use another class name, like, I don't know, like faded out or something, right, to say that a button is disabled, and those tests are going to break, but I've made a non-functional change that shouldn't have broken. And so this reoccurring thing that's been coming up, which is like, well, what if we could test like a user test? What if we could test visually? So visual regression testing is about this thing. It's about testing visual changes. I can take a screenshot using PhantomJS. I can compare it with what I've previously said is good, what is right, and then a little analysis goes on. There's an automated approach, hooks into your build system, and it comes back and says to you something's broken. And it gives you a nice little visualization like this one on the right, which it's got the thing that's told you it's moved. And I don't know whether you can notice on these two, the left and the center one, but that's not an easy change to pick out visually, right? But this brings it out nicely. So visual regression testing for me is about this idea of implicit test coverage. It's basically that, go back to that example, you've got a disabled button that has a disabled class in it, but I've changed the class to faded instead. But if you're testing that, you're testing the implementation of that disabled action, right? It's the implementation. You don't want to test the implementation, you want to test whether something's disabled or not. And at least visually, you can do that. So it gives us an implicit text coverage of CSS, HTML, and JS. It's not just the class name. I might choose markup. I might change the button from being a button tag to a link. You know, it's things like that. Just trying to remove yourself away from the coupling of X files and CSS vectors. Verifiable contract of visual design is kind of a nice side effect of this, which means that you've constantly got a visual baseline. And so if something changes, it might change deliberately. You can go to various product stakeholders or a UX design team, and you can say to them, this is changed, are you cool with that? And you can enable TDD like CSS. But previously, there was no way for me to test CSS. There's absolutely no way. Not sensible. But now I can test, but I can have a button, I can have a modal dialog, I can have a sidebar, whatever it is, and I can refactor that CSS, and I've got test coverage to support that. So, manual testing is a time-consuming process, and that's especially difficult with visual. If you're testing spacing, if you're testing padding, if you really care about that kind of low-level detail of UX, I mean, that's a lot of time to go over and make sure everything's right. You've got, probably doing it in multiple browsers as well. So this is one way of mitigating that, having some kind of automated feedback. We're in a new world now where we are doing more and more responsive design, responsive layouts, and again, like you've got so many possible variations of your UI, you need a way of testing it. Again, visual testing is perfect for this, right? Because you've got a visual side effect of a viewport. Refactoring, which I just mentioned before, again, really crucial for any kind of long life project. Not all of us have, can work on greenfield projects all the time. Sometimes you have to actually live with the consequences of your actions, and you need to change it. And you need tools to help you do that, and this is one of those, especially with regard to CSS. A good example of that, for instance, is that we adopted Bootstrap a few years ago, and now we're slowly migrating away from Bootstrap. And I can't imagine trying to do that sensibly without this kind of tool. So then identification is just about, if it's move one pixel, that's kind of a subjective thing. You really care about it, at least you can make that decision. At least if a build breaks, you can say, I do care about this or I don't care about this. And you can have that conversation. So PhantomCSS was the tool that I wrote a couple of years ago, I guess. Using PhantomJS, so we already had PhantomJS in use here at that point. So all I needed to do was, in Casper.js, so Casper.js is the tooling around that. That's basically, it gives you all the nice things that Selenium does in terms of navigation and scripting. And then Resemble.js is the image comparison library, which I wrote, which basically takes the screenshot, it puts it into a HTML5 canvas, and it does a quick comparison and tells you if something's changed. So that's what PhantomCSS is in terms of technical terms. So I was just mentioning that it's got the Phantom name in front, and we still use PhantomJS because it's fast and it's stable. But you can also use Slimy.js, and Slimy.js is a Gecko browser. It can be used headlessly or not, but that's Firefox we're talking about right now. So obviously, PhantomJS is WebKit, and that's the manages with Chrome. So you've got that kind of, if you wanted to, you've got the potential of testing on two different variations of browsers. A lot of people want to use Slime.js mainly for the web fonts and loading Flash and stuff like that, which don't get for free with PhantomJS. PhantomJS 2 has just come out. It's not stable yet. I tried to upgrade it, but it's not that simple. But that will be coming soon. That has a better compatibility with lots of different new technologies in the future. So that's a code sample. Really, we're just using Casper to say, go to this URL. We're going to click a button, and we're going to take a screenshot. The screenshot is of an element with the class modal, because we're using CSS selectors. And the modal dialog is the name of that screenshot. So you can come back to it and say, it creates two things. It creates a test that will pass and fail in your automated build system, and it also creates a screenshot for you, labeled with modal dialog, so that you can actually go and visually inspect manually yourself. So on top of the code, you've got the command line interface for running these. At its simplest, but this is just the example I pulled from the reading guide. But basically, we've got various settings. Debugging is really important when you're doing any kind of testing, generally. So the Boast login there will tell you about. It will just log everything: mass events, big events, all that kind of stuff, so you can follow through what's actually happened on the page. Obviously, if you want to use Slimer.js, then you just pass this flag. You have to install Slimer.js separately. You just pass this flag to Casper. And then web, I don't think this is supported in Slimer.js, but PhantomCSS supports this remote debugger, which allows basically Chrome debugging tools. So you can just go to any web page, and then you can do a debugging statement to the code as you run the test. So it's worth just knowing there's problems, right? There are problems with this approach to testing. I mentioned earlier that we isolate our UI, which means we have absolute control, or pretty much absolute control of our UI. But content is an issue, and especially if you're dealing with websites or whatever. If you've got useful content, if you've got like a CMS driving that, and you just can't have your visual test on that. It makes end-to-end visual testing very difficult. So you need to find ways of controlling this or ignoring it. Same with animations, right? So the thing with animations, you can predict it, and I've tried testing animations before, and they will pass time after time on my computer. But as soon as you put it into a distributed environment where you've got multiple machines running the same test, those animations run ever so slightly different speeds, and so you'll get visual problems. So I recommend just ignoring it. Web fonts, as I mentioned, you might get that in PhantomJS 2 when that's stabilized, but otherwise you're kind of restricted to using Slimer. And cross-browser, there's still a strong requirement to get coverage, visual coverage over multiple browsers, and you're just not going to get that with PhantomCSS. That's not what it's designed for. It's only for something to change. It's to help you refactor code. It's not about that kind of cross-browser element. There is a what's it called? Trifle.js. There's a headless browser called Trifle.js, which is I've not personally tried using it with this, but that's a possibility. So it's good for lots of things. It's really great for style guides and kind of libraries. Remember, this is about getting the UI into text, right? So if your style guides and components are living, if they reflect exactly what you've got in production, then it's pretty much been under test. And that's what we're actually working on doing in the current library now at Huddle. We don't have one yet, but we're working towards it. What we do have at Huddle is an isolatable UI, as I mentioned. We use that Phantom exception to mock out the AJAX requests and just use passive big buttons. By the way, release regression tests. I heard some people use it like this. They've got a big redesign or something like that, and then they just want to write some quick tests to go to a page and take a screenshot and then do a comparison after the release. They might compare multiple branches. You know, you get failures, right? But that's the point. It's about saying something's changed, what's changed. You have that conversation. So that's not the end of the story in terms of visual testing and hardware. PhantomCSS came about with lots of other tools. By the way, it was lots of other things popping up at the same time. And there's PhantomJS and no, just JavaScript, to be honest. Who wouldn't want to write JavaScript? Amazing language. And gives you that ability to just be a bit creative. And so there's lots of tools I was helping develop with the team around me. One of them was PhantomFlow, and that was about providing a bit of structure around Casper.js, a bit of just making the whole kind of flow of visual regression testing a bit more simple. And so, yeah, about helping to manage the visual baselines. This kind of BDD element, behavioral-driven design element, which is about describing user interactions, but describing the behaviors, and making that a bit more transparent. Communicating UI complexity. So really about how to best express complexity in a system. Complexity is always expressed through tests. Nearly always, unless you're testing one. You're always going to get a crap load of tests if you've got unnecessary complexity. So making that more transparent is a good way of doing that. And doing that through visualization, which I'll show you in a minute, is a good way of doing that. And we touched on it with the Selenium stuff, about parallelization. PhantomJS is fast, but if you parallelize it, it's really, really, really fast. And so, yeah, like for instance, I can run 3,000, and I do have 3,100 tests, including visual tests, and they run it in 2 minutes. I don't know how long that would take. So this is an example of flow of the code, just to give you a bit of an idea of the structure. We have a grouping, and it's based on the idea of decision trees. I don't know how familiar you are with that, but basically it's like I do an action, I make a decision, then some chance event might have happened. In this case, in the example, I've got I'm testing a responsive website. I make a decision to view it in various ports, and then I take a step, which is to go into that page. And then I'm just doing, in this case, a visual test of the entire body, which I do not recommend. CSS is really about component-driven CSS testing or visual testing. Just because why not? Yeah. If you have full-page screenshots, you're likely to get errors. You're likely to get failures. So if you just keep them minimal, as small as possible, that's going to help you out a lot. Right, so I have an example coming up. I was thinking about doing some live coding, some live testing. I chickened out. I do have a little screencast for it. Which I'll talk through. But basically, that's going to be talking about, I make a change to some CSS, I run the tests, I check the failures, and then I look at the flow visualization to look at the divs and rebase those visual tests. So basically, I just want to try and show you the whole workflow. And this, this is what we do at Hub. This is what we do for our UI testing. So this is not Huddle, in case you got confused. So it's a responsive website. Various things change there. And I'm going to change some CSS. This could be any change, but the idea is that it's potentially it's a non-functional change. I just want to make a change for whatever reason, and I'm not expecting a visual failure. So I now run from the command line, it runs the tests. It goes now to processing the visual. It tells me that 2 failures. So I've obviously screwed up here. I've broken something. What we're now going to do is have a look at the report. And this is what PhantomFlow does for you. This is the main thing about PhantomFlow. It brings up a visualization. In this case, it's really, really simple because it's just a demo screen. But it gives you this tree structure. Remember the code I showed you before, where it was showing you the decisions that the user was making, and then the end goal of the thing. Right, so if we now hover over each of these end nodes, we get the failure, we get the original. You can see that something's changed there. That one didn't write, which is great. And then something quite significant happened there. So normally I'd say that's probably a failure. But just to show you how the rebasing works, basically I say that actually this is good. I've just had a conversation with UX and said that it's fine, just accept it. So here's a button, I click the button, it's rebased. And what that's done is it's called off the Node.js server underneath, and it's swapped out those images and said that this is the new test. So I rebase those two images, I now rerun the tests. And of course, what happens, that they will eventually pass. So that's what visual regression is. Obviously, it's still on command line, but imagine this is all hooked up into the build system as well. We actually use TeamCity here. And this graph, for instance, has been published on TeamCity, so that other stakeholders and other relevant parties can take a look. That's a really trivial case. If I show you what we've actually got on Huddle right now, actually this was a few months ago, but this is the test. This is the D3 visualization we installed before. That this is with a full-on test suite. I suspect there's, I'm not going to guess how many tests there are there. It's not our full test suite. It's just the load. But basically, you can see from that all the green spheres are the ones with visual tests. You don't do visual testing for everything. I think that's worth pointing out. And it's a great tool, but you don't want to use it for everything. So visual tests and you can obviously navigate that next one. Okay. So that was a kind of introductory sweep through the way we do visual testing in Huddle. These are some links. I should probably put this presentation on Speaker Deck or something. So I've mentioned as well, but Resemble.js, which is a tool that's used by a number of, I don't know, at least one other visual regression library out there. So it's quite popular. And PhantomFlow, of course, is open source, so it'd be great to see more info on that and get people using that. That's it for me. Regression.
So just for clarity, this obviously this is based on the premise that at some point you have to take the first baseline for things that happen with the nodes. The subsequent tests will always compare against that baseline, right? And you sort of control that baseline as well.
Yeah, thanks for that. Yeah, so basically as a process, what I would do is I'd build my UI first. I'd probably write some functional tests with PhantomJS, which is buttons and check that things exist, and I'll probably do that in the TDD style, bring in practice type scenario. I then look to, when I'm happy with visual design, I've got maybe some sign up from the UX team member, a designer. I would then say, I'd then create a visual screenshot. That would, so I add in the visual test, I run the test, that creates the image, the baseline. I then check and make sure the baseline is correct. I then commit that into my Debugging code. And it's basically a test at that point. It's just an insert. So it just goes in with all your other tests, and it just lives there. And then next time you check out that repo and you run the test, it will see if it exists, and then it will compare that with the new one.
With your UI tests, do you have to deal with internationalization? How do you deal with that?
All of the internationalization is locked down. We get it all from our API, which means we have control of it. So it's kind of, in that respect, it's not under test. The actual localization is not under test itself, but the resource streams there have to exist, and so we just want that stuff out. So if the translation perhaps is broken, you don't have coverage of that. I think that comes down to a manual process. You could, I mean, all you need to do is get that resource, right? So potentially in your test suite, you could grab that resource file and use that as your mod. Well, we've gone for complete isolation, but there's ways around that. Definitely.
So currently there are many CSS regression testing frameworks available. The Backstop.js is the recent one, which is apparently called Smarter PhantomCSS. So what feature of PhantomCSS do you reckon is differentiating it from other tools, and why people should use it?
I think it's more about, if you look at, I've only looked briefly at Backstop. I know Backstop is the one that uses Resemble, I think.
Yeah.
It seems like that, and tools like Wraith, and they are more geared towards full-page regression testing. And I think really what PhantomCSS was always designed to be really small and easily integrate with Casper, and like you can separate the two. You have to use it with Casper. And Casper is about how do you navigate through the system, how do you take little portions and interact with them. And so for me, PhantomCSS is what makes it distinct from other visual testing tools is about the nature of it. The fact that you can pick out a CSS selector, you can navigate through a system, you can then pick out a dialogue or whatever it is, and you can take a little screenshot of that thing. And I know there's some work being done by the other tools, like Wraith, for instance, but this is the PhantomCSS has been there from the start. It's very much geared towards that. So I guess, you know, the other side of that, if you're just building a responsive website, or you know, you're very much about content, then you probably want to use another tool. To be honest with you, I mean, you can set this up really quickly. I'm not, but you know, there are things that are just as easy to get up and running. I don't want to sell this.
Yeah, the main issue is the QA guys needs scripting knowledge. The PhantomCSS needs some
exactly.
scripting. So yeah, so that's the technical challenge for the QA, which is not from the
Yeah, it's worth just saying that this was always developed from a development and unit testing point of view, not a QA point of view. So the scripting element makes it really powerful. It makes it much more flexible than some of the other tools. But yeah, it does create a little bit.
I think you already answered it, but for cross-browser, being a tester, cross-browser, if you have a responsive website, the array of browsers and devices that need to test is huge. And using PhantomCSS, would I be able to say I've run this test against a particular browser, or is just a unit test?
Yeah, so I have quite strong opinions on this. I personally think cross-browser testing is a dead art and shouldn't be done. I think modern browsers are very alike. I think with PhantomJS in particular, you can do various viewports, and so you can do the whole responsive element. You're not likely to see much variance. Now, yeah, there's a doubt there, right? But I have never personally seen significant regression in other browsers. I've always caught issues with this text construction. IE for me has always been more about the JavaScript and things like dunstable delete. You can't do delete keyword on object functions. And you can rule that stuff out with JS and upbuild tools. So as long as you've got your the development build stuff correctly, I've never personally seen the need for cross-browser. Also, I'm slightly burnt by this. There's a tool years back called JS Test Driver, and I tried to use that with IE and basically farmed out Jasmine tests to different browsers. It just crashed all the time. What's the point? So there's this sort of kind of cross-browser benefit thing, and for me, it's definitely worthwhile.
Last question, my topic.
one more question.
So in terms of obviously sort of using some of sort of image comparison, so I mean there are a lot of tools out there, for example, Facebook Hustling, which is really complicated.
There's several kinds of false positives, really. There's false positives that there has been a change and you don't really care about it. And there's a false positive like, for instance, anti-aliasing animations. You get variances like that. I'm not totally sure about how tools like Huxley deal with that. When I wrote Resemble, I was very much thinking about anti-aliasing because we were running on multiple systems. Some of those systems out there didn't have clear type label, for instance. So you get different font label. And so I was really desperately trying to figure out a way of making the scale, and just in this team. So Resemble deals with that. There's a little algorithm in there which says, it's a little blurred corner, I'm going to ignore it, basically. It's not perfect. But I don't know if other tools, a lot of tools use ImageMagick, for instance, for the comparison engine. And I'm not sure, to be honest, how that compares.
Actually, is much better than
Really?
because I would think it probably would do a much better job than what it did, because obviously the ImageMagick obviously sort of the algorithm that will pick my comparison is pretty much accurate compared to what I've seen with the tool. Yeah, I'm sure.
There's a degree of intelligence in Resemble that's not perfect. Initially, the first kind of CSS used a tool called ImageDiff, and this is before I wrote Resemble, which was literally the RGBA difference. And it didn't work in scale. Yeah, so you do need to be a bit more flexible in that. And also, there's a setting in Resemble. You can pass all the Resemble's got a config, and you can pass a bunch of options to it. For instance, like the pink diff, you can change the color of that if you want, stuff like that. But you can also change the tolerance. And so if you've got that situation where you've got a lot of variance, then you can just up the tolerance. You've got to lose coverage. That's the trade-off. But you can do that. That's something else. Thanks.
So we're ready to start by the way with the layer.
Yep. So guys, we are just 5 minutes break and we'll be back. Okay, let's start. Hey guys, let's start. Hi everyone. My name is Adam. I'm a co-founder of R&D at Apple. We're a company that provides a cloud service for automated visual testing. And as part of my job, I get to meet a lot of developers and testers, and I'm always curious to learn how they do visual testing. And there are two common answers that they usually give. The first one is that they have no idea what visual testing is. And the second one is that they think that I'm asking them if they're using Sikuli. So the main thing that I hope that you will take away from this talk is that you understand what visual testing is, and James already did a lot of the job for me, a very good job, and that you can, and that you learn that you can, and you should automate this type of tests. And if in addition you can put it in your mind that visual testing is not securely and tell it to everyone you know, that would be a huge bonus. So as far as the agenda goes, we'll talk a little bit about what visual testing is. I'll do it very briefly because we already covered that in the previous talk and why it should be automated. Then we'll take a deep dive into some of the tools that are out there and the technology that's behind it. And at the end, we'll talk about how visual test automation can fit into your development processes and development process. Okay, so by the way, if there is any question, feel free to ask. I'm going to the end. What is visual testing? So it's a quality assurance activity that is aimed to verify that the graphical user interface appears correctly to users, and it's not what we're used to do with Selenium and similar tools, where we actually test the functionality of the application through the UI. What we want to do is make sure that the UI itself is correct. If each UI element appears in the right color, shape, size, it doesn't overlap or hide any other UI. And here's a typical visual bug. This is one that I found in the Microsoft Azure Management Portal. You can see here that the graph actually exceeded the expected bounds of the page. And here's yet another one where this article title overflowed and covered the article text. So these are kind of embarrassing bugs, but in many cases, these bugs could really mean that you actually cannot work with the application, you're losing money if you're an e-commerce site, and now you can't click the purchase button, you're losing a lot of money, right? And
I'm sure that you'll agree with me that you don't expect today your normal Selenium test to catch these things. Right? You rely on manual testing to find them, but you should. So why should we automate this test? So there are many reasons, and James also mentioned a few of them, but just from different perspectives on that. So the most important reason is that the test metrics is just too big to approximate manually. So all different web browsers and devices and operating systems and screen resolutions, we all know that if something looks like in Chrome, doesn't mean that it looks like on Android. And we all know that if something looks like on a looks good in a wide screen, doesn't mean that it looks like on a smartphone, right? So we have to test the way that our application looks like on a huge variety of execution environments. And it's just impractical to do with manual labor, repetitive manner. Of course, if our application is responsive, and most modern applications are, then we also need to factor in the different layout modes in all these different execution environments. And as some guy here mentioned, localization. So if we're doing localization or rebranding of our application, we need to factor in the different fonts, the different layouts, the different content, different images. So it's just a huge, huge problem that needs to be solved, and it cannot be done anywhere that puts us in a place where we can feel safe to release a version. What makes things even more difficult is the trend of the recent 15 years or so, where the development cycle and the release cycle gets shorter and shorter. And the recent trend, which is continuous deployment, it dictates that whenever a developer commits a line of code, an automated process is triggered that ends up with that piece of code being pushed to production. And companies that are doing continuous deployment are releasing to production several times a day. And with such short release cycles, it's hardly possible to do any kind of manual testing, let alone make sure that everything looks like in so many execution environments. And when we're talking about mobile applications, whether they're hybrid or native, then it gets even harder because it's much more difficult to pull back changes. You cannot push data to the App Store. And even if we find clever ways to overcome that, then frequent updates will take battery and data and eventually upset your users and reflect badly on application. And in general, there is a much higher quality bar for mobile applications just because the fact that mobile users are much less tolerant to UX and UI bugs. So we even need to test more thoroughly these types of applications. And of course, a very good reason for us as people that are practicing software engineering, a good reason to do things is because many others are doing it. And in recent years, because of the reason that I just mentioned, many companies have incorporated automated visual testing into their test processes, respectable companies. They've built excellent tools like Hubble did. They share them with the community. And there are thousands of other companies that are using these tools on a daily basis to do automated visual testing. Any questions about the motivation before we move on to the technical stuff? Okay, so there are many visual test automation tools out there, but the vast majority of them follow this four-step work, which is the same for all. The first step is where you drag the application on the test and take screenshots. Different tools provide you different means to do that. Some tools provide you with a Webdriver that you can use to interact with the application and get the screenshots. Other tools have their own domain-specific language to do that they invented. Yet another type of tools allow you to provide just a list of URLs or just a base URL, and the tool will crawl from that URL to a website and take screenshots of every page it uses. But basically, the end result is that you have many screenshots to check. The second stage, the tool actually takes the screenshots and compares them with baseline images. And these baseline images define the expected appearance of the application. These could be images that were taken in the past and previously approved by a human that saw that they're okay and valid. Or they could also be screenshots that were taken simultaneously at the same time with the images that needs to be validated only from a different execution environment that we trust. Okay, so a very common practice is to take screenshots from your staging and from your production environment of the same application state. Okay, and you use the production screenshots as a baseline to compare the staging screenshots with, we assume that production is good because we previously tested. In the third step, the tool gathers all these match results and builds a report. Okay? And in the fourth step, a human has to look at that report, look at the differences, if any were found, and decide for each difference whether it's a bug, and then hopefully we fix the bug, or at least open the bug. And if the difference is a valid change of the application, you just need to approve it so it would become the baseline for subsequent runs. Okay, so that's the basic workflow that almost all the tools follow. Now that we understand the workflow, let's see a demo of one of the tools that I really like. It's called Webdriver Css. It's an open source tool. It actually augments WebDriver I/O, which is one of the popular JavaScript WebDrivers, and it allows it augments it with visual test functionality. So let's take a look at that and see how it works. Before we start looking at the visual regression testing stuff, this is a very simple test with WebDriver I/O. It has nothing to do with visual testing at this time. And what this test does is that it forces it to create its own WebDriver. And we indicate here that if we wanted to open up a Chrome browser, what the test does is that it starts the browser, it then navigates to this project on GitHub, and it waits for 10 seconds. Okay, a very, very simple test. Actually, it doesn't test anything. But let's run it and see what happens. Okay, so we just started Chrome, and you can see also that the page does not fit entirely within the browser bound, so we have to scroll down. And we wait for 10 seconds and get on. Next, we're going to add visual validation using Webdriver Css, and this is very easy to accomplish. By the way, I'm showing it with Webdriver Css, but almost any WebDriver language binding that exists today has a visual test tool that augments it. And it looks generally the same, the additions that we showed. So we create an instance of Webdriver Css, and we use it to actually augment our WebDriver with the ability to do visual regression testing. We also indicate the screen width in which we are interested to test the application, and this is very useful if you have a responsive application and you want to test it on different layout modes. Okay. And what we do in the test here today is just after we navigate to the URL, we call this new command that was